Okay, hi everybody. So, give 5 examples of sequences. And no two can be similar, whatever that means. Okay, so part A. Let's give 5 examples. Here's the sequence: 1, 2, 3, 4, 5, ... forever. But what is this? Well, I should really give a formula. The nth term should be n. Okay. Maybe here's another way to say it. X sub n should just be n. So like here, this is x sub 1 is just 1. Here, x sub 2 is 2, etc. Okay, there's one example. Let's do this example. 1 minus 1, 1, minus 1, 1, minus 1, 1, minus 1, ... Okay, well, what is this? Well, I better give a formula. How about the nth number should get sent to what? Well, how about -1 to the n plus 1? Okay, so, or another way to say that is that x sub n should be -1 to the n plus 1. For example, here's x sub 1. It's equal to -1 to the 1 plus 1, which is -1 squared, which is 1, as it is. Here is the second number, x sub 2. We say x sub 2. Or in Perusall, if you wanted to type this, you do slash parenthesis, and then you can type some math. So for example, you could type x underscore 2, and then slash end parenthesis. And then when you pressed enter, your Perusall comment would type like that, with a nice subscript. Anyway, what is x sub 2? -1 to the 2 plus 1, which is -1 to the third, which is -1, as it should be. Okay. Let's see. How about this sequence? 1, 2, 6, 24, 120, 720, ... Now, this one you really don't really know maybe what I'm going for here. So I'm going to take the nth number and I'll send it to n factorial. And this is just a symbol. What this means, the definition of this symbol is n times n minus 1 times n minus 2 times all the way until 2 times 1, and that's it. You know, or I could even show you 3 times 2 times 1, and that's it. So, for example, x sub 4 is 4 times 3 times 2 times 1, which is 24. Let's check. I don't even know if I got 720 right, so let's see. X sub 6 equals 6 factorial, which means 6 times 5 times 4 times 3 times 2 times 1. This is 30, and this is 24. And I can multiply these together. 30 times 20 is 600, and 30 times 4 is 120, and in fact, that is 720. Excellent. So we could also write this as x sub n is n factorial. That's a formula. Okay, that was the third example. How about this example? I minus 1 minus I, 1. I minus 1 minus I, 1, ... And of course, I don't know what ... means, so I better give a formula. X sub n is equal to I to the n, which just means I times n times. Okay? And so remember, I equals 90-degree rotation. And so we can picture this sequence as starting off at I, which is over here, and then multiplying by I again gives I times I, which is I squared, which is minus 1, which makes sense because if I rotate by 90 degrees, I'm at minus 1. I to the third is rotate by 90 degrees I squared. But I squared was minus 1. So I rotate minus 1 by 90 degrees, and I'm over at minus I. And we keep going like that. So this is a good formula. And in other words, if I take a natural number, I'm going to produce a complex number. The natural number little n gets sent to I to the n. This is the formula. Formula for a map. Okay. And also, we sometimes this is called the index. Well, really, it's not called the index there. It's only called the index when I say x sub n. Then the n is the index. Okay, that's just a word that people use for this. Okay, great. That's another example. How many did I do? 4, and it wanted 5, and they can't be similar. Okay, how about this one? 1. Okay, 1, 1/2, 1/3, 1/4, 1/5, 1/6, etc. Okay, but what does this mean? Well, I better give a formula. X sub n is 1 over n. In other words, as a map, we're going to take the natural numbers, and I guess this is, yeah, these are real numbers, but they're also rational numbers. So I'll take little n, any natural number, little n, and I didn't have to call it little n. I could call it little m. And it's going to go to x sub m, which is defined as 1 over m. Okay, so for example, 3 gets sent to x sub 3, which is 1/3. There it is. Okay. So I chose a different index here, or just chose a different name for my index. Okay. And good. That is part A. All done. Interesting. Okay. What precisely is a sequence? Explain the different notations people use. Okay, so let's do this one in purple. Okay, how about over here? What is a sequence? A sequence is a map from the natural numbers usually called n. If you wanted to write this in Prurzal, you'd say math b n, and these are like curly braces. Yeah, and it would make this nice n for you. You'd have to wrap it in a slash open parenthesis and a slash end parenthesis. Okay. Into, well, where should, okay, so now I'm realizing a real, or how about this, an integer sequence, or a rational sequence, or a real sequence, or a complex sequence. These are all different. What are they? So, basically I'm saying, oops, this isn't good enough. Is a map from n into, well, maybe the integers, or from n into the rational numbers, or from n into the real numbers, or from n into the complex numbers. Okay, we could call this map F. Maybe this one I'll call G, this one I'll call X, this one I'll call Z. Okay, so then, each of these is some sort of a rule. And so another notation is to write maybe x sub n, and put it in parentheses, and then say for n in the natural numbers, or x sub n, and n equals 1 to infinity, or x sub n, and this one I don't like because it makes it seem like n could be a real number, anything greater than or equal to 1, like over here, forever. That's not true. The index is always a natural number. See? The inputs are always natural numbers, so I don't like. But you might like, so that's fine. People use this notation. Another notation is to say x1, x2, x3, x4, x5, x6. The problem is you can never stop. x7, x8, x9, x10, x11. But so what people do is they write these, which are slash dots. That's how you do it in LaTeX. So you could do slash left parenthesis, slash right parenthesis, and the computer will make dots in a formula for you. You can also try slash c dots. What does that do? Slash v dots. What does that do? But anyway, so better is to say n goes to x sub n, or n goes to x of n. And that way you could, if this map is named that, then you'd take an input and you'd say x of n. Or, for f, you could say f of n equals n factorial, maybe. And that's how we usually write down maps. So you can do that too. So did I answer the question? What precisely is a sequence? A sequence is a map. It has an input, which is natural number, and an output, which can be different kinds of numbers for different kinds of sequences. Explain the different notations people use. Yeah, I explained a few of them. I mean, if you call this explaining, a lot of it I did verbally, but you can just sort of put in words what I said, or just probably enough. I mean, what are the basic things? I mean, people sometimes write it out like this. Like that's what I started doing with each of these. I sort of wrote out the beginning of a list. So one notation is to write out the beginning of the list. So write out the first few elements of the sequence. That's one notation that people use. What's another? Just write down a formula, like x sub n equals some stuff. Formula. Or another is to just write down a map. But by the way, this symbol here would be slash maps to in LaTeX or in Perusall when you're typing comments. You have to get math mode by doing slash parenthesis in your comments. If you type this, it begins math mode, and then you can exit math mode by typing slash right parenthesis. And then they'd give a formula, like n factorial, or 1 over n. Okay, those are sequences. I guess that's all I want to say. They are maps. A sequence is a map. Map is another word for function. Map is the word for function. If you've never heard of the word function or the word map, go to Wikipedia and type function mathematics or map mathematics, and you will get a very nice explanation. And you should know, because that is what a sequence is, and this course is called Complex Sequences and Series. And a series will actually turn out to be a sequence, in a certain sense. Can you do this? Quiz yourself. This is sort of knowing the basic language that we're going to use for this course. So take out a blank sheet of paper and see write down this, or just pause the video right now so you can only see the question, and see how much you can remember. Put it in your own words, make up different examples than mine,